highlights on Drilling 101, and then we're going to open it up to our panel of experts. They have a couple slides. But the idea here is to talk about, the basics, foundation, and what we're considering as we're qualifying contractors and as we are drilling and all of these pieces. So I'm going to go very fast so we can get to our great speakers, but I wanted to have a base foundation here. And so with that, I have a warning for all of you in my favorite 90s MTV TV show. So I'm going to try to do this as well as I can. The following panel features tribal drilling knowledge acquired by drilling professionals with the supervision of geothermal and groundwater professionals. Accordingly, Brock, Yordy, the GDA, NY-GEO must insist that everyone who engages with this presentation and these professionals consider the following. Drilling is the imperfect combination of science, physics, and self-taught tribal knowledge compounded over years of success and failure. Drilling is a disruptive process. The key to success lies in your conscious choice of the drilling program that minimizes the impact on the surrounding environment. Drillers, contractors, engineers, scientists, and clients have entered a powerful partnership to uncover the mysteries of the subsurface. Mother Nature's cooperation in being part of our geothermal revolution is optional at this point. So if we look at 10 years ago, geothermal systems, as I have so many great engineers and other professionals in this room, we've changed a lot. And it's a significant piece to think that we were 300 to 500 foot holes, less than 6-inch in diameter, drilling mud rotary was pretty much the predominant. 1.25-inch loops. Ball State, we did dual 1.25-inch loops in a 6-inch hole to 400 feet. And that was insane at the time. Grouts, bentonite, cement, sand was our thermal enhancer over graphite. Kevin's father was the first one to field test a thermally enhanced single sack graphite grout back in 2008. Project size, 5 holes to 500 holes. Ball State was that first moment that we went, wait, we're gonna drill 3,600 holes in one location? So today, we jumped 10 years ahead. We're working through the 500-foot rule and those regulations right now, but it's John Travacco said it best to me one time on a call. He goes, Brock, you're trying to have a field day where we're drilling like it's the 90s and you only want to go to 400 feet. We got to show these people how we get to 850 or how we get to 1,000. And I agree, it's just, that is no longer a single day of drilling, where we used to see 400 and 500-foot holes very easily drill 2 holes and have them looped and grouted in the same day. George Lucas Narrative Arts Museum, we did 3 holes a day to 500 feet, 710 holes under the substructure of the museum. Today, we see diameters from 6-inch to 8.5. We have the professionals with Darcy here, and we have dynamic closed loop that are 12 and 14-inch wells. We get into all sorts of different specialty drilling methods. We heard about coil rigs today. We're going to hear from Colt about advances in technology. We have foundation, we have legacy, water well, and geothermal up here. Loop diameters, 1.25 to 2-inch. Grouts all over the place, from graphite to nanotech to cement to low carbon. Type 1 Portland is not the same as what Type 1 Portland once was. We have many things changing in our dynamics. Project size, what does Princeton want to do, like 8,600 holes total? You look at what we're getting into everywhere. So we think about this. When we're going into Geothermal 101 and Drilling 101, like, what's it going to be about? Location, right? Should there be a Starbucks here? I said that earlier. Project feasibility, budget, stakes, the state and local regulations, test hole logs and data. And, Josh and I were just lamenting at the end of the last panel about we're doing this geothermal revolution and we're drilling these holes all across the country. And it's the greatest data set that we could possibly have for advancing what we want to know about thermal energy resources. And it's the Wild West when it comes to how things are logged, how things are maintained, that's back to that tribal self-taught knowledge, from stocking caps to cowboy hats, how we're drilling this stuff. We have to consider it. Construction timeline. I don't know how many projects I get pulled into, or as the Geothermal Drillers Association, where they go, cool, we have 65 holes to 850, 65 days, right, Brock? And I'll tell you, the biggest significance right now as we get into these things is weather. From Mayor Wu shutting down projects, 2 Mays ago because it was too hot to work, to significant rain events, to tornadoes. So, as we look at our Gantt chart and we have project timelines and liquidated damages, it is significant to consider how our weather patterns have changed and how significant that changes our ability to execute on time. And then contractor qualifications and capabilities. And as we heard in the first panel, and we'll hear here today, they have the right tool for their region, or when they come to this, they have a means and method that they want to execute with that will give them the best chance of mitigating risk and getting us to bottom at the best rate possible. So as we look at a drilling company's selection process, comes back to equipment availability. We're talking coiled tubing today. There's a dozen coiled tubing rigs in the geothermal space right now. Conventional mud rotary rigs that are from the middle 2000s and older, there's plenty of them out there. So as we look at track mounted and we look at European methods, we have to consider the best tool may be the most readily available to get us into that space and getting going. Again, location history, data, geology, test logs, test holes. From a selection process, all three of these guys right here would say, customer and engineer are 100% one of my drivers, and if I'm going to bid this project or not. Right, Kevin? Yeah. Hole specifications. As we look at doing 1.5-inch loops, and we go, well, we want to save money on grout, so we're going to go to 5 5/8 hole or smaller. We have to consider at 850 the size of trimmy that's going in with that loop to be able to pump that grout effectively. That trimmy has to be on the bottom of the hole to positively displace up. And so if we're going to go to bigger loops and bigger trimmy, deeper depths, we have to be able to have a size borehole that can fit all of that and effectively grout it and seal it. Because we think of that grout as thermal enhancement and the lifeblood of that system, but it is also what is protecting our groundwater and our subsurface, and it has to meet permeability standards and has to be able to stand up to the geology and the chemistry, subsurface chemistry there, and we'll get into that today. Loop installation, timeline, and staffing. We talk about, well, we want to get to 3 individual rig crews, or 4. I'll tell you what, if you're drilling an 850-foot hole, it takes 4 individuals. You have one that is running a bobcat or a skid steer moving those cubic feet of material that's coming out of the hole nonstop to have site management. And that gets to site management and then other project commitments. So this is what it looks like for drilling project management. What is success? Weather, other construction operations on site, local regs, location, project timeline. And that drives right into, how do I work in this area? What man-made obstructions? What are my neighbors' requirements? Hours of operation, site size, site management. When I'm thinking of drilling program management, that's when I get into what's going to impact my success. The ones in green, we can plan for and execute. The ones in orange are the problematic areas that we really need to start thinking. And that comes back to what subsurface utilities are there? What was there? This is a great green space, but how is it impacting us? To industrial pollution from PFAS to Gen X chemicals and how that's impacting us. We have formation hydraulics, meaning how much pressure can I exert on that borehole before I start eroding it? Cool, we decided we were going to drill in a 5.5-inch hole, but I'm now trying to drill it at a rate that I'm doing several hundred feet an hour. What pressures am I putting there and eroding that hole out bigger? To water, high volume zones of water, wellhead protection areas, and then artesian flow, methane, H2S, other volatile gases. As we go into urban markets and everything else, this is a significant piece that we have to be prepared to deal with, but also we have to have the right contractors that are qualified to do it safely. There's a Variety article from 15 years ago that says they're drilling geothermal next to my house and I want to blow my head off. Like, that's still out there. When we Google geothermal, that comes up. Also, Jack Diana was like 70, I don't know how old Jack was at the time, but I'm just going to say Jack was quoted in it. Last slide, and I'm going to jump to these guys. Borehole creation. This is what the basics look like. I'm exerting force. I'm creating a cutting. That cutting has to be somewhere between a 1/2 inch and 1 inch. I like to think of nickels and quarters. That's what needs to effectively come out of the hole so I can manage that site. Next thing, how am I rotating? what is my force, what is my velocity, and there's drilling rates and speed that are going to determine the equipment we use to bring those solids out of the hole. And then it's all about cutting removal and solids management. Soren talked about that, but this is the significant drilling 101. If I can get those right, I can do it. And this is what I need out of my Mother Nature aspect to what does my qualified contractor look like. And now I want to jump out of these and get to Kevin's up first. I'll leave us right here. Lessons learned. We have to safely complete these projects. We have to understand what tooling and equipment is available, because as a classically trained Bayreuth and Halliburton guy, yeah, I can tech this to a level that we could have $2 to $3 million worth of equipment on site. Is that cost effective? Or is mud rotary and that rig that the local driller has that has been successful in that area, is that the right tool? So as we look at all of these pieces, we have to understand, for us to get to the scale we want to in wide scale acceptance, we have to be able to use all the tools and empower all the qualified drillers we possibly can. Kevin, you're up.
Thanks, Brock. So, of course, we do these things last minute, and I'm not always great with slides, but we did have some fun videos that I wanted to get out there to show some of the joys that we see in the geothermal world. Just a minute ago, Brock was talking about tools and selection and qualifications, and when we had a pre-meeting last week, I showed these guys what I consider to be the most valuable tool in the industry, and I don't care which aspect you're talking about. It's right there. It's meetings like this. It's the expansion of our network, talking to engineers, talking to geologists, talking to building owners, talking to people in different parts of the country. Somebody has done it in a location before. So being able to pick up a phone, call, have a question, figure out what the risks are, what they've seen, what the correct methodology of designing a bore field is as simple as a phone call away. And that is one thing that the industry has really evolved over the last couple of years, say the last 10 or so years, between just in New York State with NY-GEO and the Empire State Water Well Drillers Association. They work really closely together. We do have to protect our most valuable resource, which is our groundwater. We also have to continue to try to improve this state's and the country's energy usage. And so if you go all in on attacking and putting boreholes willy-nilly without knowing what's underneath your feet, what the risks are, you start damaging the water side of things, you're going to get shut down real quick, really, really quick. Tool-wise, you know, I think this is the only video that we actually got, or is it just a picture? Escape. Aowen's going to come and, this is, that's not the one we wanted. But these are some of the things that we see. Oh, let me get out of the way then.
I don't know if I can fix it, but.
Just never mind.
Don't smash it with a pipe wrench.
Second favorite tool. There's always a hammer bigger. Now we lost the whole screen.
Because it wasn't in person.
Okay. At some point in time, I have all kinds of fun videos on my phone showing flowing conditions, artesian brine, gas ejections, very, very forceful means. So those are the things when we look at different areas of New York State, when we look at a job, when we start talking about things, is it safe to go to this depth or that depth or this depth? We see it all the time where, you know, one of the rallying cries as we headed down this legislative regulatory action that we've started a couple of years, deeper's cheaper. No, not always. Sometimes it makes sense that you have to go to 1,000 feet or 1,200 feet because that's what space you have underneath your feet. It doesn't mean that it's applicable everywhere in New York State. We are working right now with the DEC on the shallower parts of 500 feet, making it so that we hear it from USGS, we hear it from engineers, we hear it all over the country. We need more data. We are going to get into a spot where we're going to be able to require that TC tests and drill logs for geothermal are provided to the DEC so that it's publicly available. Sharing that information makes every job that we do easier, and again, it's the most valuable tool that we have in this toolbox. We've seen all kinds of drill technology over the years of doing this, more than I even thought we'd see or learn about 10 years ago. There's no right way. Every single piece of equipment is the correct piece of equipment if the operator running it knows what the geology is going to show them. That's all that matters. We prefer to use what we call a Swiss Army knife. It's big, it's mounted on a truck. We can get most places, but no, we're not going to track rig into Brooklyn or underneath a building. Every tool is there. That's all I got for right now.
Thanks, Kevin.
Who's up next, Mike?
I think it's Mike Fleming.
Sorry. You would have thought that I would have done that with my...
So I just press enter? Arrow?
Space bar. Next space bar. Don't hit it with a pipe wrench.
So, no pipe wrenches anywhere? All right, we're good. My name is Mike Fleming. I'm a superintendent with Phoenix Foundation Company. We're a union drilling contractor based about an hour outside of Boston. As a drilling contractor, you know, I'm sure anyone who would be can resonate with everything that Kevin just said. It's really all about where the job is, what the geology is, who are the drillers that you have afforded to on that site. As we approach this industry, it was kind of the machinery that we use, pictured up here, micropile rigs. They're not designed for drilling geothermal holes. They do the exact same thing. They spin, they go round and round and push things down in the ground. It was kind of a mode of, you know, run what you brung. That was what we had available to us. We wanted to get into this market and use what we had. As far as drilling techniques go, using this equipment, you know, the advantages that have been afforded to us is the fact that these machines specifically have very high-powered heads and retraction systems on them that make them capable of, you know, 50, 60, 70,000 foot-pounds of torque. And that's what allows us to very efficiently install casing where, you know, subsurface competent rock is 150, 200, 250 plus feet below ground surface. This specific job, Maryland McCormick Housing Development, South Boston, Mass. Rock was supposed to be around 240 feet deep. We figured out that that was not the case. It was about 200 feet. But we were setting 200 feet 9 5/8 casing in 45 minutes. You know, hole to hole, it was a few hours, but the actual spinning pipe and getting it down, if he was set up the day before, we could be on coffee break before or right after the hole was down the next morning. So that's kind of how we have adapted Phoenix's systems that they already had in the foundation industry to the geothermal industry. It's worked well for us so far, but you know, myself and my colleagues, we've been very vigilant in all of our, you know, goings on where we attend these types of conferences, go and see other pieces of equipment around the world, around the country. It allows us to look and see where other companies are going, companies like Republic, companies like Hammer and Steel, what they're offering, and how we can use different systems on site in order to expedite our production. There's a few more pictures of that site. But it's, for us and for any drilling contractor, it's about adapting. Whatever you have, whatever Swiss Army knife you may hold, it's getting it to the site and getting the job done. So this is the approach that we've taken to do that.
Thanks, Mike.
That's about it.
Hey, that's me. Hey, Colt McCarthy, CEO of Republic Drill Co. Come from a family drilling business. My dad, late father, started a company in 1977, Venture Drilling Incorporated, and we did water wells, geothermal, and aggregate mining, drilling and blasting. And so I got the privilege of growing up in this industry, and I've had the privilege of working in it professionally for 20 years. And one of the more, I think, fun seasons has been this season getting involved with the geothermal community. Because for the most part, we've been selling the same rigs to do the same things to the same people in the same areas year over year. And while that works, there's not a lot of innovation in that space. And this industry has pushed my boundaries because it's made me question what we're doing, how we're doing it, and then where can we find the next tool that can do it better? Because solving for pain points makes all industries better, and we haven't had a lot of solutions poured into this industry for a long time. We've had a lot of people that do it the way they've been doing it, and it's gotten by, but now we have a lot more pressures and constraints, risks for not getting it done appropriately. And we're talking about the urban drill sites and very large projects with penalties for time delays, penalties for poor performance. And so people have to invest in different technologies to make sure that the job can get done the way it's supposed to. And it's challenging, like they said at the panel before us. Most people in this industry really appreciate challenges, and that's what drives us to keep moving forward. That's not my notes, not my person. So one of the things that we had the privilege of being introduced to a while back was we'll start there. So with NY-GEO, we have recently partnered with NY-GEO as a supplier for drilling equipment. NY-GEO they're going on their 40th year manufacturing equipment, and what we've seen from the rest of the world, they have many tools in their toolbox for doing projects. And these companies that have been manufacturing global machines on a global scale have taken a piece of the way they do it around the world, and they keep adding that into their engineering documents, but two, in how their rigs work. And so you end up with these rigs that when we look at them, we say, wow, these are all great new innovations. And the reality is they probably didn't think that up themselves. They solved somebody else's problem somewhere else in the world, and that became something that we can all appreciate and use. And so more tools in the toolbox is really what we're bringing with these brands, from dual rotary rigs to tiny rigs that go inside buildings to really big rigs that have a lot of power. That's one of the ways that we're helping bring different innovative solutions into the industry. The thing that is most new to us and new-ish to the industry is a product that we came out with and helped continue to develop called the loop loader. And if you've been in paying attention the last couple of days, getting loops in the ground and getting them grouted is the heart of the geothermal system. And sometimes it's very challenging to do that. Even if the hole is drilled right, it can be very, very challenging. And the loop loader takes the geothermal loop and it goes on the front of the machine, and then it uses a coiled tubing injector head and coiled tubing system to drive the loop down into the borehole. Because loops are, they're malleable pieces of plastic essentially. And so the longer and the more you push on them, the more like pushing a piece of spaghetti through a straw. It doesn't work good when you push on them. So we apply all the force at the bottom of the loop, and it really helps drive the loop down. And we can put about 2,000 pounds of force at the bottom of the loop as we're pushing it down. And then once we get the loop in, we can use our coil tubing pipe that pushed the loop in. It becomes our trimmy pipe now, and we grout through that pipe. And so one of the standards of IGSPA and setting loops is that you grout from the bottom of the hole every time. That way we ensure there's no air pockets, there's not water, there's no voids, and the borehole is sealed off appropriately, and the thermal conductivity that we're expecting from that specific loop is extracted from the hole. And so this machine, it's only been available to purchase for about a year, and hopefully we'll see it more widely adopted as it solves more challenges. But at the same time, it's not the machine for every job. When you drill good, clean holes in rock, you might not need to have a loop loader at all. If you have shallower holes, you might not need it at all. But as we continue to grow in complexity, and we're talking about 1,000-foot holes, we're talking about 1.5-inch loops, 2-inch loops, they're pretty rowdy. I mean, they don't want to bend. They want to float up out of a hole. And so it takes more solutions to continue to solve for the new problems we're creating, like 1.5-inch, 2-inch quad loops, things that are much larger than what they were before. I mean, it wasn't that long ago before 1-inch loops was a big loop. And so we're doubling we're doubling our capacity, hopefully, and we're also sometimes doubling the challenge that it takes to do the same job. And then one thing for me personally is that we were Venture Drilling Supply for almost 40 years, and we rebranded to Republic Drill Co. a couple years ago. And part of the rebrand was also getting to tell a different story and a new story. And one of the things I've seen in this industry growing up in it is you've got men and women, they've worked really hard, and they've made a lot of sacrifices to gain the knowledge that they have. That could be your physical health, it could be time away from your family, missed baseball games, basketball games, recitals, whatever that you have family events that you've sacrificed to be out in the field or to be solving problems in this industry. And there's many more sacrifices that we make. And the thing when I look back on the employees that we had over 40 years, the ones I'm most fond of are the ones that were passing on knowledge to everybody around them. And we hit a wall, it seems like a decade ago, where you can't learn from me unless you want to learn how I learned it, and that was the hard way, right? So that's how you're not going to get taught by me until you prove yourself worthy to be taught. Well, we walked away with the whole generation that's didn't learn much, and they're not good teachers because nobody taught them. And so that's what we have today. And so we are very passionate about passing on knowledge, and I call it redeeming the sacrifices made. So there was a lot of sacrifice made to learn something. Make sure someone else gets the chance to learn that information. And so that's one, we have to be teachable. Two, we have to be looking for people to teach. And so part of the ethos that we have and that we want to encourage the industry is to keep passing on knowledge. And as Kevin said with the phone, be willing to share knowledge. Don't look at people as your competitor, but also think of, man, I paid a lot for this knowledge. I want to bless others and let them have the same knowledge that I've fought hard to learn. And the thing that we're most excited about as our brand is that we don't care if you're running a Jeffco, Atlas Copco, a Frosty, a Kamakio, a Costa Grande, whatever machine you're running. We want to be able to bring everybody into the same umbrella. And so we are for the drilling industry. And hopefully, as we are for the drilling industry, we can help elevate others to say we are the drilling industry, and we are part of the republic that makes up the drilling industry. And so one of our biggest goals is to foster community across the drilling industry. And so we're very thankful for this time to talk about that, and really excited that you guys are here to listen about drilling. And I got a question. Who didn't know anything about drilling before they came this week? All right. Well, I hope you learned some more. Thank you.
You know, Colt was the first sponsor of the Geothermal Drillers Association. Without Colt's first initial funding, we couldn't have filed the paperwork with the lawyer for the nonprofit to be the Geothermal Drillers Association today. So he's definitely been a champion, the same as Kevin Moravec has found a place on the NY-GEO board, but also in the Empire State Water Well. And New York State does the best job at communicating with the groundwater community and the geothermal community. There are many other states where we have blockers and bottlenecks and things that happen. And I think a big piece of that is the fact, as Colt just alluded to, about what do you know about drilling? Less than 11% of our voting population has a water well. There's only 14 million water wells in the United States. Yes, many people drink groundwater through municipalities, but we need to let it sink in that drilling is not common. And if you do have a water well, if you're out of water, you can drive over that flower bed, you can make as much noise as you want, and you can execute on getting a new water well because you want water back. But now that we're doing this geothermal push as big as we are in more places, it's very significant to understand that we have to be surgical and quiet and neighborly. And there's so many other aspects to a massive drilling disruptive process. And so I have questions, but we have 25 minutes, and I respect your time and your knowledge. If you have questions first, let's open it up to our panel of experts.
Hi, my name is Joshua Chung. I work for Frontier Energy. And Brock, I talked to you yesterday. I appreciate your conversation. I kind of want to piggyback on what we said last night. How do, you and the panel plan on, reaching out to the younger generation, people of my age, people who are graduating out of college that are looking for jobs? How are you going to talk to these guys that the drilling industry needs the newer generation? And on top of that, how is the older generation going to communicate with the newer generation, kind of exchange ideas? Because I think that it needs to be even further and kind of talk to high schoolers and middle schoolers that this is a new generation of jobs that is coming to afloat. So, thoughts? Thank you.
Take it away, Kevin.
So, a lot of ways to answer that question. So, historically, let's just focus on New York State. Drilling has always been a family, very localized business. Son learns from father, from grandfather, all the way through. My company was founded in 1934, and so I'm the fourth generation. I may or may not have a fifth generation living in my house at 16 years old. Drilling is messy. Drilling is hard. It's hot. It's consistent. There's no shutting down in the middle of an operation because you want to take a little break. That's probably one of the biggest things that is difficult for somebody coming into the industry. It is also greatly rewarding. When you get somebody water in an area that is at risk, they love you. You're also solving probably the greatest growing need that we have is heating and cooling buildings in New York State. How do we attract people into this industry? Simple. We pay you. We pay you more than you're going to get to go be a teacher by a factor of 3 or 4 or 5. We have drillers that make over $250,000 a year. They have no formal college education. They started right out of high school. And so there's a choice to that. You have to want to do it. Drilling and running a rig is in your blood. And it may be generational blood, or it may be the first time you get around the piece of equipment and it gets into you. Like you love it, or you don't. And when you find somebody that loves being around the rig and interacting with the homeowners and the clients and drilling in a unique situation and solving a problem, man, it's great. So that's really what it is you have to come to us. We will hire you. We will train you. We will pay you. And then we will hopefully get you in a position where either you stay with us and you're part of our family for a long time, or, hey, you've got the knowledge, you've got the ability, here's the business plan, go buy a rig. Get started. We'll help you. We don't view additional drillers as competition the same way that we used to. I've worked with just about every single drilling company that's executed something in New York State over the last 10 years. We collaborate. We need more of us. We need to keep the knowledge flowing from old to new. And then we also need some of that new generational perspective in what we do in our industry. So if you ask, we will hire you.
I think it's significant to realize that there's 164 million Americans that work every day. There's 8.3 million that work in construction. When we get into drillers, and this is the DOE liftoff report, it's 19,000 drillers in the US right now. And you think of the footage we need to do in New York, or you look at the footage we need to do in Massachusetts or Colorado or Illinois, we've taken up the entire capacity. And so we do need a whole new generation coming in. We have to empower, and we also have to figure out how to transfer that tribal knowledge, as we've spoke about, because right now for every 50 applicants into the construction industry, one goes into the drilling industry. 20 years ago, for every 28 laborers going into the construction industry, one was going into the drilling industry. So it's a big deal. And the difference between our shrinking construction industry now from back then was the average high school dropout rate was 15% in the 90s, and now it's less than 5%. And so there are lots of avenues and lots of cool jobs, or these regional buildings that send boxes with smiley faces to my house, and it's climate controlled, and they have 401k. So we have a mission, and we need you. Go ahead, Colt.
Yeah, I would say that the precursor to what Kevin's talking about, and a key point, what he said, we will pay you well. Before, drilling was something in generations past, it wasn't the best paying job. It was, you did it because it was your family business, or because I say you're either born into it or you fall into it. That's kind of how you end up in the drilling world. And that's not going to grow us. So that is a reactive mindset. And so I think from an industry perspective, the branding of the trade needs to be leveled up continually. And that's one thing we're doing as a company, is trying to brand Republic as something that is attracting to the industry as a whole. And I think every company has to be doing something similar to not necessarily rebrand themselves, but say who they are. And that's social platforms, that's attending events like this, that could be community outreach, high school job fairs, college job fairs, there's things like that. But our brand is our story, and as we're talking about in the industry, we have to have the right optics, is a phrase we've heard here this weekend. So you have to also promote your brand, and it's hard to say that because you have to know your story well, communicate it well, and then also show communicate that through images and through posts and through consistent things like that. And so the recruiting aspect is going to have to be leveled up. And there's honestly a roadmap's already been played. The dirt world, the construction industry has already kind of laid that path out, and they're showing how successful they can be at recruiting excavator operators, dozer operators. And while it is different, they have showed that they can elevate the cool factor of the industry back to what it used to be.
So there's so many different ways you can perform the kind of outreach that's needed to bring in the talent that this industry needs. I think something that's been really effective for me, getting people attracted to the industry, is just being proud, being outspoken, being, having that story be compelling. Powerful, that people want to listen to, people want to get involved in. It's, if it's someone's dream to go work at a hot dog stand or anywhere else, and they wake up and they love it, and they're shouting from the rooftops that that's what they love to do, they'll probably attract more people because of that rather than the person who hates their life to work up at that hot dog stand. And you hear the old time operator of any equipment that moans and groans and complains, and which is, even if they love the job, it happens a lot. Nobody wants to listen to that, one. Definitely not me. And certainly not prospective, teachable employees. So that's a position I've taken, is just being outward, being proud, being proud about what we're doing in the industry. Everybody knows what an excavator is. There's probably not a person on this planet that can't say
Willie.
they say like, oh, it's a tractor or an excavator. It looks like that, but you show them a picture of a drill rig. I'm like, what on earth is that thing? I don't think I like it. There's a lot.
Next question.
Hi, I'm Cheryl from Arab. We are engineering consultant, and I'm a geothermal designer. I have mainly two questions. The first question is regarding timeline. I have a good, bad problem where I convince my client to do a geothermal system, and they're like, yes, let's do a thermal response test yesterday. But then I was talking to a drilling company, and they said that they are booked all the way to October. So question to you is usually how much lead time do you need from engineering consultant firms like us? That's the first question. The second question is, in your experience working with engineering consultants, what is something that we could really improve on so that we can make your job easier and make my job easier? So for reference, I actually write thermal response specs, but I think it needs to be very localized. Disclaimer, I moved from like SF in Singapore. I'm just new in New York, and I want to write a spec that is not going to get laughed at. And I just want to get the job done. So please educate me on how I can do it better.
I'll make it simple. You've got to be real careful what you promise your clients when you're trying to get somebody else to perform a test like that. We do operate on next year. Today is next year. It's 2 years. It's 4 years. Our businesses are very expensive to operate and run. So we can't just sit there and have excess capacity waiting for what we're doing. If you have a drilling company that can get in to do something that quick, you might wonder why. And then to the second part of the question, what can you do to make it easier, and what kind of spec are you looking for? I mean, there's all kinds of examples out there. The biggest thing is logs. Like, really get that drilling log. The TC test, to me, it's not that important. Half the time, engineers don't even use it. They don't even look at what the ground is going to do versus the heat pumps they put in there. I'm not saying you.
The views of Kevin Moravec may not be. No, I'm just
may not be represented at large, but it's the construction of that borehole. What that well log is the single most important piece to the bidding process for every other driller that looks at it. If I'm the one that drills the test well, and I'm the only one that bids that project, there's something wrong with that. Conversely, if I'm the one that drilled it and I'm not bidding on that test hole, that's an indicator to other drillers that there's something that might not be good with this site. Those are just a couple of the key pieces. And if it's a smaller project, there's a partnership aspect. I saw a gentleman, my thought popped his head. He's sitting in the back of the room right now, Jens Panekow. Partner, as drillers, partner with your designers, with your contractors. Situations on site change, and so you have to be fluid. If you're on a small-ish project and you've got a total footage in mind and you have a TC number that's most likely really close, the work has been done in the area before, you can call drillers and get a sense of what those numbers are going to look like. But just because you think that it's going to be a 500-foot hole and you got to do 50 of them, all of a sudden you hit something that's unforeseen. You have to be able to change. We did a project in Buffalo that started at 500, went to 450, went to 400, finished at 350. All in the span of a week because of what the geology did to us. And so we made it safer, we made it more effective, we changed our grout type, all midstream, but it was a collaborative process with the entire design team and the execution team. Can't be dogmatic. As long as you have room and you have the ability to work through those problems, it makes it easy.
I think it's significant when we're doing test logs or test holes that, you know, I see some of these come out and they're like, well, how fast can they drill it? And the test hole is not. At Ball State, you know, that first 1,800 holes, Triton Geothermal on the South Field took the first 5 holes and really dialed in their drilling program, and then was able to execute much more swiftly because they had a solid drilling program put in place from what they had from test hole data, but then what they dialed in along the way. So getting a test hole driller out there and the money we're going to spend to the thermal response test is very significant, that it's drilled effectively and that we didn't erode the hole, or we ran it with a hammer and we supercharged that entire zone because we pumped 100,000 gallons of water and we changed the transmissivity. There's so many pieces, and we got 2 brilliant people right up here in the front of the room that are like, we want more data. And for us to be able to log the significant changes to every 5 feet, or how we would do it for a parking structure, is something that we need to better hold this industry accountable on. Go ahead, Mike, sorry.
Totally fine. Just ×2 on everything Kevin said. Again, communicate as early as you possibly can, and your test programs. Being 10 toes in, beginning to end, is huge. I mean, I feel like it's a certain portion of the project where you kind of have to really equalize between cost and value. The value of that test program is priceless when you're using it to design the rest of your project. So, I mean, the proof is there. If the log says it's 500 feet of sand and gravel, and the technician that was on site that day didn't even get out of his car, it gives me nothing. And it's going to be expensive when we're drilling 100 test holes because we didn't know what the job was.
Next question?
My name is Mark Williams, CT Mel Associates. All the gentlemen up there, including the moderator, spoke about how relationships help drive innovation, how the collaboration amongst all of you help fix a problem because of those relationships. Kevin alluded to the fact of the strong relationship between NY-GEO and NY-GEO, and the Empire State Water Well Drillers Association. I also would challenge that we build those relationships with the utilities, the regulators, the design professional groups, such as the professional geologists, the various professional engineering groups, because I think if we're all pulling the rope in the same direction, I think we grow this particular market sector farther down the road, because we're all doing things in each of our own best interests so that we get what we want and we can provide opportunities for new college graduates and have them understand it. But the one thing I would say to how Kevin originally answered the question from the student is, one of the things I've seen as an old graybeard is when I first dealt with drillers in my early life, I appreciated the extreme hard life they have. Every day is production. Every day is somewhere different with grout in your face when it's -20 out. It's a tough life. But the one thing I've learned to appreciate is they are just as much of a professional as I am. And I really appreciate that input. And that collaboration is a multitude of levels, because if I ask a question to Kevin, I'm going to get a localized answer that's better than any database that I've been access to. So, that's my 2 cents, if it means anything.
It's significant for us to recognize that the $4.5 million worth of capital equipment that drilling company has, that's their master's degree. That's, as we look at investment into this industry, that is, yeah, and it's obviously can go higher and higher, but that's. Higher than a master's. Yeah, oh yeah.
Scar tissue is what he meant to say.
Next question.
Hi, John Sheets with CT Mail Associates. I'm a geotechnical engineer and coming in with a different background to this conference. I guess I wanted to ask, Mike maybe, what experience you have, or have you seen any engineered, deep foundation systems that are integrated with geothermal systems, and some of the issues with construction or design that might not, be expected that you've run into?
It's a really good question. It's something that I think the industry has been calling for. It really all comes down to who is going to pay for that test. Nobody wants to answer that question because nobody wants to pay for what they don't know. Remember the first IGSPA convention that I went to, conference that I went to in Champaign, Illinois.
Talking to the mic more.
The first IGSPA conference that I went to in Champaign, Illinois. I listened to Masi Alavi speak. He's a engineer, geothermal engineer from GEI. He was speaking about energy piles, bunch of different kinds of abstracts. I'm not aware of any systems that have been installed in an actual borehole.
It's one right down the road in Greenwich, and
Well, there you go.
Google building. So yeah, Andron. Sorry.
They
Yeah.
have been in slurry walls, though.
We need we need energy piles. We need drilling in buildings. We need angle drilling. We need to be harnessing every thermal energy resource we possibly can, and your experience is going to help with that. So it's not, for us as drillers, there are plenty of times that we say drilling's not the right application here. Or where can we get all the right resources to have the best holistic approach to build the best bore field so that we continue to excel this industry?
Hi, I'm Luis. I just was drilling in central Pennsylvania. Question, you will have the case of two people, one with it will be like a skilled driller, very like a knowledge about drill pipe, operating the machine, threads, everything. On the other side, like just like a recent graduated engineer, like a civil engineer, geotechnical. Which one you will hire? And to the one that you wouldn't, what reason you will tell him because he was not hired? I'm asking because I'm a third generation driller. My grandpa was a driller. My dad is a driller. I was a driller. Now I'm more into the machine. And I'm geotechnical engineer. Thank you.
So the question is from experienced, skilled versus classically trained, or, yeah. Again, why we've excelled in this industry, and Kevin's about to hop into it with the insanity of the drilling conditions he has in Western New York. But, that local tribal knowledge is invaluable. And we joke a lot, but experience is what you get when you didn't get what you wanted on completing that job, right? And so having the local knowledge is 70% of the battle.
Yeah, I mean, drilling is drilling in some applications. So if you can run a piece of equipment, and we've taken environmental drillers, and we've converted them into water well drillers, geothermal drillers. If you have knowledge on how a rig works, that's the basis for what, that's a good starting point. for getting into the industry. Is there an educational aspect, an engineering aspect, a geological aspect, a hydrogeological? I mean, everything that there is out there that can improve your knowledge base on what you're seeing beneath your feet, that's a plus when you come into the industry. We'll teach you what you need to know to put the bit into the ground, but those extra bits of knowledge just make it easier for you. Jens is dying for a question, I think.
Per John Shabako, you better use that microphone.
John Gerarco. I'm Jens Parnikow with Buffalo Geo. I think we're missing the most important thing here, and Kevin was alluding to it. I usually refer to them as to a network of drillers in different areas of the state because we're drilling all over, and I don't bid things out. We have an agreed price because he needs to make some money, and we have to put a borehole in and have to make some money on it. Otherwise, we can't operate. So if I know already that Kevin is doing this job, he's going to do the test borehole. Because I don't want any complaints later on and say, oh, you didn't tell me that. But he also can trust that he's not going to run into a surprise unless, of course, you drill a test borehole, which is dry, and 20 feet to the side, you have a gauger.
Which happens.
Which happened, yes. But then, or you hit gas, or you hit anything, and then you run into trouble. But then you trust each other. I trust him that he's not going to cut corners. He's not going to put peat gravel in there instead of expensive grout. He puts the grout in there I want, and he knows exactly the way I want. You know how easy it is to work together? If I'm calling him, he doesn't have, and I'm not calling 10 others and wasting the time of 9 others to give me a bid, or wasting Kevin's time to give me a bid. You know how easy it is to go in there and say, hey, Kevin, 20 more boreholes there, and a week later, can you do 10 over there? And how much we save in efficiency and just moving forward. And he knows that he doesn't get played where somebody else shies away from it and the test bore is not what you thought it is. And it saves him half the time on a job. And the other 10 days he can go and do another job. How much is that worth? And at that time we were sitting there and said, okay, we're hitting gas at 400 or 380 feet. We designed with 500. And there was no gas 20 feet to the side in the test borehole. Now what? And literally 20 feet to the side of that, there was an 80-foot gauger. Remember those times when you douched all those cars on the street on the traffic light across the street?
Jens walks out of this building right next to this. We're drilling 700, 800 feet away down in an alleyway in Buffalo. He's walking into the building, walks out of it, sun shining, he's got his sunglasses on, life is good, as Jens loves to say. We're all standing there with a look of abject terror on our face because we just threw 1,000 gallons of water into the middle of an intersection during rush hour in Buffalo. And it was the color of this tablecloth, and it wasn't just water, it was rocks, it was mud, it was a little bit of everything. What's the big deal? But we figured it out. And so that's a key thing from Jens' perspective also. Very involved in every step of the process. That's where some of these competitive bid or engineered solutions that go out to bid and complicated structures of how these projects go to ground, the more involved you can be as a designer and the accountability and the relationships and the partnerships that you can develop with every aspect of the trade to get your client's solution executed correctly, it makes it easy for the drilling community to invest. Jens needs an extra 200 bores, and he tells me he's going to do it for the next 3-4 years. We're probably going to buy another rig. I'm probably going to hire another person or two. That long runway is really what helps us grow our industry.
Yeah, and
Starts
instead-
and stops is not
Yeah, and
positive.
instead of stopping right there and saying, oh my God, we got to get to a halt, we need to reevaluate the situation, we need to redesign everything because we're hitting a huge amount of gas at 380 feet suddenly. Well, you know, Kevin, you keep drilling, we're doing 350 feet boreholes now. And how many do you need? I don't know, but I'll come by tomorrow and let you know. Okay, we rearrange the piping a little bit, we have to buy a little bit more pipe. I give Kevin 20 grand more, and we're all good. And there was no delay, and we finished ahead of schedule instead of pausing for 3 weeks until everybody figures that out.
Yeah, operating
What's the
at
deal?
speed of trust is a big piece, and who you choose to work with as a client or a customer or a driller because Mother Nature's cooperation is optional, everybody, and it's just the way it is.
Yeah, and then he gets paid within a few days, and we're all good, and he gets some down payment ahead of time, and let me know where the next borehole is. You know how efficient this can be?
And this is why Kevin's 2 years out, is because Jans has him on full lockdown. So we got to find 5 more Kevins and 10 more Mikes and a dozen more Colts. And
This is really, you have to have a trustworthy relationship. It is not about the bid, because you know how much money you can save by just pounding away and getting this job done in half the time, and your guard doesn't have to be up all the time, and you don't have to wait for the money, and all the other stuff happening, and then you sit there and say, not a big deal. Let's keep drilling. Let's get the pipe in the ground. I'll let you know when to stop. So instead of 35 boreholes, we did 50. We did them shorter. What's the big deal? Right?
It's never a big deal. Just keep going.
See?
thanks, everybody. I know it's 4:05, and I don't want to be in trouble. Thank you.